This video is focusing on some more similar triangles. Now you may notice that the one on your screen looks different than the ones we've been seeing. The ones you've been seeing have been two triangles that are separated from each other. They may have been rotated or reflected, but they have been separate, such as these. So what we're going to be talking about for this one is when you have two triangles within each other. So here we have a smaller triangle inside of a larger triangle. You have your small triangle here that I'm outlining in black, and then you have the much larger triangle outside of it. So I want you to think about how these triangles are sharing their sides. The smaller triangle has a side that is part of the larger triangle. And we're going to use that idea to figure out what our missing side length is. So what I always tell my students to do is to think about these as two separate triangles, and the easiest way to do that is to draw them as two separate triangles and label what you know. So I'm going to start off by drawing my smaller triangle and labeling that I know the bottom part of it is 14 and the side of it is X. So I have outlined and redrew the small triangle. Now I'm going to redraw the big triangle, which I'm outlining in red. So over here I'm going to draw the larger triangle. I'm going to write what I know. Okay, I know that this side here is 63. Okay, this is showing me that the whole side length is 63. And I know that my bottom side length is 42. Once I split up the triangles, you can tell that it's the same thing you've been doing. Okay, so it looks a lot less scary. You can always tell that the two triangles are similar if two of the sides are parallel. Our 14 and our 42 are parallel. Now it's just a matter of lining up our corresponding sides. So I've got X over 63 equals 14 over 42. And then I'm going to cross multiply, just like I've been doing. So I've got 42x equals 63 times 14, which is 882. I'm going to solve for x by dividing both sides by 42. That gives me that x equals 21. So the main thing here that I want you to see is that once you split up the triangles, they look the same as what you've been doing. Now let's look at another example that's slightly different. And when you look at this, the first thing that you need to recognize is that you do not have the whole length of your larger triangle. Alright? So let's redraw it with our small triangle. So I'm going to draw my small triangle first. I know this is 6 and this is 5. Then I'm going to draw my larger triangle. I know this is 15, but I really don't know what this side is. I know that it's going to be 5 plus x, but I don't know what the whole length is. So what I can do is I can figure out what that whole length is and then figure out what x is. So that's what I'm going to show you how to do on this one. We're going to solve for the whole length. Okay, we're going to leave it as a question mark for right now. So I'm going to do the same thing we've been doing and line up my corresponding sides. So 15 over 6 is equal to, now this is my question mark. This is my big side. I don't know what that is. So I'm going to put a question mark divided by 5. Okay, so now I'm going to cross multiply. 6 times something, we don't know what, equals 15 times 5, which is 75. Okay, now I'm going to divide both sides by 6. That tells me that my unknown long side of that triangle, 75 divided by 6, gives me 12.5. Now that is not x. Not x. Okay, I want to put some exclamation points there. To find x, what do we need to do? If we know that the whole side is 12.5, we can figure out what x is by subtracting 5 from 12.5. So 12.5 minus 5.0 gives me 7.5. So your answer is x equals 7.5. So I'm going to give you some questions to go along with this to try your hand at drawing your own triangles separate. So make sure that you complete those and submit the Google form.